Hey everyone, welcome back to the another lecture of Introduction to Data Engineering. In this lecture, we are going to see limitations of Hadoop and evaluation of data lake architecture. So Hadoop provides us distributed storage that in the form of HDFS. Second thing Hadoop provides us is operating system to manage the cluster like Yarn. And the third thing Hadoop provides us is processing engine to process the data, and that is nothing but the MapReduce processing engine. These things collectively combine with another one more layer, and that is data access and data retrieval layer, and it combinedly formed as a term or a notion called data lakes. So, or data lake architecture. Let's see some add-on that are available in data access. The first one is HBase. HBase is an open source non-relational distributed database, and it is a columnar database that is developed on the top of Google's big data papers. Then the second thing, Hive, Apache Hive is an open source warehouse software project, and it is built on the top of Apache Hadoop for providing query capabilities and analytics capabilities to give an SQL-like interactive interface or SQL-like interactive query to query the data. So this is the Hive. And the third thing, for real-time processing or machine learning workloads, we have Apache Storm and so on. Like multiple solutions are created on the top of Hadoop, like Apache Storm, Pig, and so on. So let's see what exactly comes after all these things. So we have these four layers in the data lake architecture. And in our Hadoop era, these all layers are either provided by Hadoop or they are provided by some extra softwares that are built on the top of Hadoop. But in the era of cloud, as cloud evolve, you can see we have multiple solutions for distributed storage like Azure Blob, Amazon S3, Google Cloud Storage, and even our native Hadoop HDFS as well. For cluster managers, we have Yarn, Kubernetes, and Mesos. For processing engine, Hadoop MapReduce is there, and one other more powerful and the most popular processing engine, that is Apache Spark, and some other data access and retrieval tools like HBase, Hive, Scoop, Storm, Pig, etc., that are developed on the top of Hadoop. This totally combinedly known as lakehouse architecture or data lake architecture that are adopted by most of the companies that are dealing with big data. So let's see why all these technologies are developed. Definitely, there are some limitations in Hadoop. That's why all these technologies are needed to develop, right? So let's see what are the limitations of Hadoop. And the first limitation of Hadoop is performance. Why? You know, Hadoop uses MapReduce to process the data. And in the MapReduce, it reads the data from the disk of the specific node of that cluster or worker of that cluster. It processes the data and write the data again on the disk. So that is another overhead or workload for Apache Spark that will directly impact to the performance to serialize and deserialize the data. The second thing is ease of development. MapReduce programming framework is it's a complex framework in itself, and creating the MapReduce jobs or MapReduce code for the complicated data processing operations or applications is a very hard. So creating ETL pipelines and ETL processes is very hard, and it's not the cup of tea of everyone. It's just few skilled engineers and professionals that can do a best possible code or perform optimization code in the MapReduce framework. Then the third thing is language support. And Spark on Hadoop only supports for Java or JVM based languages. So that is again a problem because in the data world, most of the professional use SQL like tools or SQL like things. And in the Hadoop, we have to use external software like Hive. Then the storage is again another problem with the Hadoop. Why storage is the problem? We are offering distributed storage, right? But as cloud era grows and Various cloud vendors like Azure, AWS, or Google provided very cheap cloud solutions and where you can upscale, downscale, and store a large amount of data. Where in your Hadoop cluster, if you want to increase the capacity of your cluster, you have to add new machines or new workers in your cluster, and that is a costly affair as compared to the current cloud native storage solutions. And the fifth is resource management. And resource management or like operating system for the cluster is again another thing. Because in the new or modern cloud era, we have solutions like Kubernetes that are more performant than Yarn, but Hadoop restricts us to the Yarn. That is the biggest problem. So here Spark come into the picture to solve all this problem. The first, Spark is almost 10 times faster than Hadoop or MapReduce to process the data. It is able to do that thing because Spark uses in-memory processing. We will see what is in-memory processing later in the future. Then ease of development, because Spark used to provide us SQL-like query engine or data frames. In the best case scenario, you are going to code like a SQL. You are working with a database. And in the worst case scenario as well, you are either working with data frames or RDDs, and that are nothing but your language native objects like Python or Java collections. Then language support. Spark supports Python, SQL, Java, Scala, this variety of languages. And for machine learning purposes, Spark support R language as well. Storage. Hadoop restricts us to HDFS storage only, but Spark supports cloud native storage as well. So you can use like Google Cloud file systems. You can use Azure Blobs. You can use Amazon S3. These are the cloud solutions that are available. Then resource management. Spark is basically deployed in the two type of mode. Either you can use your native Hadoop cluster where you can use Yarn, and you can use the cloud mode of the Spark with some vendors like Databricks, and where you can use Kubernetes or other type of clusters, cluster managers or resource manager tools. So these are all the things that are provided by the Spark and that overcomes the limitations of the Hadoop. This is all for this lecture. What the Spark is, what is architecture, how it's work better than Hadoop. So we will see you in the next video. Till then, happy coding.